welcome to the SUI online classes. So students, I am going to teach you a new chapter, probability. As you all know about the concept of probability because you have learned about probability in previous classes. So students, in class 12, we have to study conditional probability. Conditional probability. So what is conditional probability? Suppose capital A and capital B are two events. Suppose capital A and capital B are two events associated to a sample space S. Suppose capital A and capital B are two events which are associated to a sample space S. What are events? Events are the subset of sample space. You all know about it very well. Suppose capital A and capital B are two events which are associated to a sample space S. That is, A is subset of S and P is subset of S. So once again I will repeat this definition. Suppose capital A and capital B are two events which are associated to a sample space S, that is, A and B events are the subset of sample space. What is the definition of event? Definition of event is the subset of sample space. So the subset of sample space is called event. You know it very well. So probability of event A happening depends on the occurrence of event B. So probability of A is called conditional probability when event B is already happened. So what is the definition of conditional probability? I will repeat it again. So what is the definition of conditional probability? So you have to learn the definition of conditional probability by this way. Suppose two events are associated in a sample space S. The name of those events are capital A and capital B. So conditional probability of A when event B is happened. So probability of A when event B is happened is called conditional probability of A. And when probability of B is to be found when event A is happened, then we said it is the conditional probability of B. I mean to say that if probability of A depends on the occurrence of event B, then it is called conditional probability of A, and probability of B is depends on the occurrence of event A, then it is called conditional probability of B when event B is happened. So what is definition? Probability of A is called conditional probability. It is denoted by denoted by probability of A, because we have to find the probability of A when B event is occurred. Occurred means happens. So what is the symbol? Probability of A we have to find. We have to find the probability of A. Condition is this, that B is already happened. So we will denote this it by probability of A by B. It is called conditional probability of A when event B is already happened. So what is the meaning of probability of E by F? You can say it denotes the probability of F when event F is already happened. Or you can say it is the conditional probability of E when event F is happened. It is denoted by probability of E by F. And if someone asks you the meaning of probability of B by A, then you will say that it is the probability of event B when event A is happened. So I think you are understanding the probability of the definition of conditional probability. So I will repeat it again. If probability of A is defined when event B is occurred, then probability of A is called conditional probability. And if probability of B depends the occurrence of event A, then probability is called conditional probability of B. Now, formula of probability of A by B and probability of B by A. Once again, I will define the meaning of this symbol. This symbol has meaning probability of A, conditional probability of A when event B is happened. And this symbol is denoted. This symbol is written by probability of B when event A is happened. So I think you all are understanding. So formula of probability of A by B and probability of B by A. So probability of A by B is defined by probability of A intersection B upon probability of B. This is the formula of probability A by B. Means this is the formula of conditional probability of A when B is happened. Where probability of B is not equal to 0, because if we take probability of B 0 in this formula, so this portion becomes infinite and probability cannot be undefined. And probability of B by A is equal to probability of B intersection A upon probability of A. In this case, probability of A can never be equal to 0. I think you will learn these formulas. What is the meaning of probability A by B? Probability A by B means conditional probability of A. Conditional probability of A when event B is happened. Event B is happened. And similarly, what is the meaning of probability B by A? Meaning of probability B by A is conditional probability of B when event A is already happened. So this is the concept of conditional probability. Now I will write some formulas which are useful to use conditional probability. You have to learn some formulas by which you have to solve short questions related to conditional probability. First formula is probability of A union B. You all have learned this formula in class 11. So I will repeat all formulas which are related to conditional probability, which you will use in the questions of conditional probability. Probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. You all have to learn these formulas. Second, probability of A intersection B bar is equal to B bar का मतलब what is the meaning of B bar? B bar means probability of event B not happening. Bar means not happening. B bar means event B is not happening. Probability of A minus probability of A intersection B. Third, probability of A bar intersection B is equal to probability of B minus probability of A intersection B. Fourth, probability of A bar intersection B bar is equal to A union B whole bar. Fifth, A bar union B bar is equal to A intersection B whole bar. Bar means complement, not happening. Complement of A intersection B. These are some formulas which you have to learn to solve the simple problems of conditional probability. Now I will take some simple problems which are asked in 1 marks in board papers. So students, here are some problems which are asked in board exam. These problems are asked in short questions. That means in 1 marks or 2 marks. These problems are so simple. So I can solve first problem. First problem is if E and F are two events. Suppose E and F are two events. So what are events? Events are the subset of sample space. If E and F are two events such that probability of E means probability of event E happening. Probability of event E happening is equal to 0.6. Probability of event E is equal to 0.6. And you also know that probability of an event can never be less than 0 and greater than 1. Probability of F is equal to 0.6 and probability of E intersection F is equal to 0.2. So we have to find here students probability of F is 0.3 and probability of E intersection F is equal to 0.2. Then find probability of E by F and probability of F by E. That means we have given some probabilities. Probability of E is equal to 0.6. Probability of F is equal to 0.3. Probability of E intersection F is equal to 0.2. And we have to find probability of E by F and probability of F by E. So what is the meaning of probability E by F? Meaning of probability E by F is the conditional probability of E when event F is happened. So what is the formula of probability of A by B? Similarly, we can write, we know that probability of A by B is equal to probability of A intersection B upon probability of B by definition of conditional probability, where E is not equal to 0. So we have to find probability E by F. That means we have to replace A by E and B by F. So A is equal to E and B is equal to F. What we will get? Probability E by F is equal to probability E intersection F upon probability of F, where probability of F is not equal to 0. So you can check probability of F is not equal to 0. So this formula is correct for this condition. So what is the probability of E by F? Probability of E by F is equal to probability of E intersection F. What is the probability of E intersection F? The probability of E intersection F is given as 0.2. And what is the probability of F? Probability of F is 0.3. After solving this particular problem, you can find probability of E by F is equal to 2 by 3. This is our first answer. Now we have to find probability F by E. So again, we will use the formula of probability of F by E. So probability of F by E is equal to probability of F intersection E. Probability of F intersection E upon probability of E. By this formula of probability A by B. In this formula, we will put A is equal to F and B is equal to 3. If you have learned the probability of A by B, the formula of probability of A by B, then you can easily convert it probability F by E or probability E by F or any other one else. Where probability of E is not equal to 0. The probability of that event which lies in denominator can never be equal to 0, because in this case event E is already happened. So probability of E cannot be 0. So what is the probability of F by E? Probability of F by E is equal to, we can write F intersection E as E intersection F by concept of sets. In sets we have studied that A union B is equal to B union A and A intersection B is equal to B intersection B. So we can write probability of A at E intersection F as probability of E, F intersection E as probability of E intersection F upon probability of E. So what is the probability of E? 0.6. Probability of E is 0.6 and condition is probability of E can never be equal to 0. So you can check probability of E is not equal to 0. So we can solve it. Probability of E intersection S is 0.2 upon probability of E. Probability of E is 0.6. This gives us 2 by 6, and after solving one line more, you can find probability of F by E is equal to 1 by 3. This is the answer for this problem. Now I will solve second problem. What is the second problem? So I will the problem number first. Now we will read problem second. Solution of second problem. Read all the problems of probability carefully. We have to find probability A union B. To find what we have to find? We have to find probability A union B. What will be given to us? According to the question given us 2 probability of A is equal to probability of B is equal to 5 by 30. This is a condition which is given to us in this question. That means twice of probability A is equal to probability of B is equal to 5 by 30. And one more thing is given. I will answer it as equation first, and one more thing is given in this question, probability of A by B. Probability of A by B means 2 by 5. This one is given us. Probability of A by B means conditional probability of A when event B is happened. So what we have to find? I will come second problem. union B is equal to probability of A plus probability of B minus probability of A intersection B by formula. We know that probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. So if I want to solve this problem, that means the value of probability A union B, I have to find probability of A, I have to find probability of B, and I have to find probability of A intersection B. If I will find the values of this probability, then value of this probability will come. So from where we will find these values? We will find these values by using equation first and second. So from equation first, you can observe we can put 2 PA is equal to 5 by 30. So from equation first we can put 2 probability of A is equal to 5 by 30. By solving this we will find probability of A. What is the probability of A? Probability of A will be 5 by 26. This is the probability of A. So I am success to find probability of A. Now from equation first you can put probability of A is probability of B is equal to 5 by 30, and so you will get probability of B is equal to 5 by 30. Now I have found the probability of A and probability of B. Now one probability is to be one probability is still to be found. What is the probability of that event? We have to find probability of A intersection B. So in second equation you can see from equation second probability of A by B is equal to 2 by 5. So what is the formula of probability A by B? What is the formula of the probability A by B? The formula of probability A by B is equal to probability of A intersection B upon probability of B. You all know about it. Is equal to 2 by 5. So we can write probability of B in cross multiply. So we will get probability of A intersection B is equal to 2 by 5 into probability of B. So what is the probability of B? Probability of B is 5 by 30. So this becomes 2 by 5 into probability of B means 5 by 30. 5 is cancelled out, so probability of A intersection B is equal to 2 by 30. Now, all values are come, probability of A, probability of B and probability of A intersection B. So we will put all the values of this probability in equation second. So from equation second, probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. So probability of A union B is equal to, what is the probability of A? Probability of A is equal to 5 by 26 plus probability of B 5 by 23 minus probability 5 by 13, sorry. Probability of A intersection B is 2 by 13. So now we will solve. Probability of A union B is equal to, taking 26 as LCM, in numerator we will find 5 plus 10 minus 4. That means 11 upon 26. This is the final answer of this question. 11 upon 26. Probability of A union B. Now, it is time to solve problem number 3. What is the problem number 3? Problem number 3 is given us probability of A is equal to 3 by 8 means probability of A happening is equal to 3 by 8. Probability of B happening 1 by 2. If there is A bar, then we will write is probability of A not happening. Probability of B happening is equal to 1 by 2 and probability of A intersection B is equal to 1 by 4. Then we have to find probability of A bar upon B bar and probability of B bar by A bar. Now, what we have to find? We have to find first probability A bar by B bar. So we know that probability of A bar by B bar is equal to, if I read A bar as A and B bar as B, so I will use formula probability A by B. What is the probability of A by B? Probability A intersection B. In this problem, the work of A is A bar intersection B means B bar upon probability of B. That is probability of B bar. In class 11, you have already studied that probability of an event happening and probability of an event not happening. This is the symbol of probability and probability of an event happening, and this is the probability of an event not happening. The probability of both event happening and not happening is equal to 1. You already know about it. So I can write probability of A bar upon B bar is equal to we know that A bar intersection B bar is equal to A union B whole bar. So we can write A bar intersection B bar as A union B whole bar upon, what is the probability of B bar? We can write probability of B bar as 1 minus probability of B. By which formula? By this formula. If we replace E by D, then this formula becomes probability of B plus probability of B bar is equal to 1. So we can write probability of B bar is equal to 1 minus probability of B and probability of B is equal to 1 minus probability of B bar. So I have to find probability of B bar. So we will use probability of B bar is equal to 1 minus probability of B because probability of B is given to us. And similarly, in this way, we can write probability of A union B. If you read A union B as A, then you can read it probability of A bar. So what can we write probability of A bar? We can write it 1 minus probability of A by this formula. So we can write probability of A union bar is equal to 1 minus. So we can write probability of A union B bar is equal to 1 minus probability of A union B upon 1 minus probability of B. This is the value of probability of A bar upon B bar. Now, here is a problem. I have the value of probability of B, but I don't have the value of probability of A union B. But I will use the formula of probability of A union B in this portion. So what is the formula of probability A union B? Formula of probability A union B is probability A bar upon B bar is equal to 1 minus probability of A union B. Formula of probability of A union B is probability of A plus probability of B minus probability of A intersection B upon 1 minus probability of B. Now, Here comes the solution because I have converted this whole question in probability of A, probability of B and probability of A intersection B, and value of this probability is given to us. So now problem can be solved if you have calculated correct. So what is the probability of A? Probability of A is equal to 3 by 8 plus probability of B. Probability of B is equal to 1 by 2 minus probability of A intersection B is equal to 1 by 4 upon 1 minus probability of B. So probability of B is 1 by 2. This gives us probability of A bar upon B bar is equal to 1 minus, here we can take LCM, take by which we can get numerator 3 plus 4 minus 1 upon 1 minus 1 by 2 gives us 1 by 2. So probability of A bar by B bar is equal to 1 minus, this gives us 3 plus 4, 7, here gives us, this gives us 2. 3 plus 4, 7, 7 minus 2, that is 5. 5 by 8 upon 1 by 2. 1 minus 5 by 8 is, 1 minus 5 by 8 is 3 by 8 by 1 by 2. 2 comes in numerator and 1 comes in denominator in multiplication. This gives us 3 into 2 upon 8 into 1. That is, final answer is 3 by 4. This is the answer of probability. This is the answer of probability A bar by B bar. Now we will find probability B bar upon A bar. We know that probability of B bar upon A bar is equal to, if I read B bar as A and A bar as B, then this gives us probability A by B. What is the formula of probability A by B? Formula of probability A by B is equal to probability A intersection B. Here A is B bar, intersection B is B bar upon probability of B. So probability of B means A bar, where probability of such event which lies in denominator cannot be 0. Here probability of A bar means event A is not happened, is not equal to 0. So probability of B bar upon A bar is equal to probability. We can write B bar intersection A bar as A bar intersection B bar upon probability of A bar. So probability of B bar upon A bar is equal to, we can also write A bar intersection B bar as A union B whole bar by formula upon, and we can write what probability of A bar is equal to 1 minus probability of A. Same as probability A bar upon B bar. Now probability of B bar upon A bar is equal to, we can write probability of A union B whole bar as 1 minus probability of A union B upon 1 minus probability of A. Now we have to find value of probability A union B, by which we can use formula of probability A bar A union B. What is the formula of probability A union B? Formula of probability A union B is equal to probability of A plus probability of B minus probability of A intersection B upon 1 minus probability of A. So probability of B bar upon A bar is equal to 1 minus probability of A is 3 by 8 plus probability of B is 1 by 2 minus probability of A intersection B is equal to 1 by 4 upon 1 minus probability of A. Probability of A is 3 by 8. Probability of B bar by A bar is equal to 1 minus, here we will take LCM as 8. This gives us 3 plus 4 minus 2. You can solve this portion by taking LCM upon 1 minus 3 by 8 gives us 5 by 8. Probability of B bar by A bar is equal to 1 minus, this gives us 5 by 8 upon 5 by 8. 1 minus 5 by 8. Calculation of 1 minus 5 by 8 is 3 by 8 upon 5 by 8. 8 and 8 is to be cancelled out. Probability of B bar upon A bar is equal to 3 by 5. This is the answer of probability B bar by A bar. So you can see here I tell you the some problems related to conditional probability which can be asked in short marks. Now I will teach you the theorems based on conditional probability. Theorems based on conditional probability. These theorems are important. Theorems based on conditional probability. Conditional probability. Theorem number 1. Theorem are so simple. Theorem 1. If capital A is an event associated to sample space S. Sample space S, then probability of S by A, then probability of S by A is equal to 1 is equal to probability of A by A. This is the theorem number first, which is related to conditional probability. Proof. If capital A is an event associated to sample space S, given us a event capital A which is associated to sample space S. So what is the definition of event? If capital A is an event, then it is clear that A is subset to sample space S. So since capital A is an event which is associated to sample space S, that is A is subset to S, A is the subset of S. Then we have to prove that probability of S by A and probability of A by A is equal to 1. We have to prove that conditional probability of S when A is happened and conditional probability of A when A is already happened. Both are equal to 1. So what is the concept? So first we will have to define probability S by A. We know that probability of S by A is equal to probability S intersection A by probability of A, where probability of A is not equal to 0. By this formula of probability A by B, we can write probability S by A is equal to probability S intersection A upon probability of A. Now, if you observe that event is the subset of sample space. So, if we take sample space by rectangular box S and event by circle A. So this is the condition by Venn diagram. You all know about it in sets. So capital A is the subset of S. You can see capital A is subset of S. So what is the intersection of A and S? A intersection S is, intersection means common portion between those figures. So what is the common portion between this circle and this rectangle? So common portion of A and S is A. So A intersection S is A and S intersection A is also A. You can learn if A is subset to B. If set A is subset to B, then A intersection B or B intersection A, both are equal to A, and A union B and B union A both are is equal to S. So what is the common portion between A and S? So common portion of A and S is A. So we can write S intersection A is equal to A. So probability of S by A becomes probability S intersection is A upon probability of A. Probability of A and probability of A is cancel out. So probability of S by A is equal to 1. Equation number first. We have proved probability of S by A is equal to 1. Now we will prove probability A by A is equal to 1. So this theorem is complete. Now, what is the formula of probability A by A? Now, probability of A by A is equal to probability A intersection A upon probability of A. So, what is the intersection of A from itself? The intersection of any set from itself, A intersection A gives us A. A union A gives us A. So, what is the intersection of A and A? A intersection A gives us A upon probability of A. This becomes cancelled out and gives us 1. So probability of A by A is also equal to 1. So from equation first and equation second, we observe that probability of S by A and probability of A by A is equal to 1. So from equation first and second, probability of S by A is equal to probability of A by A is equal to 1. This theorem is proved. Now, it is time to tell theorem number second related to conditional probability. The statement of theorem 2 is if capital A in any event, capital A is any event associated to a sample space as then prove that probability of A bar upon S is equal to 1 minus probability of A by S. So in this theorem, capital A is any event associated to a sample space S. Given us capital A is any event associated to sample space S, then A is subset to S. It is simple because A is event, yet event is the subset of sample space, so A is subset of S. We have to prove that probability of A bar means A naught, A bar by S is equal to 1 minus probability of A by S. So how can we prove it? We can prove it by simple way. First we will find the value of probability of A by S, and then we will find the probability of A bar by S, and after manipulating few lines we will find this theorem. So what is the probability of A by S? We will find probability of A by S. We know that probability of A by S is equal to probability of A intersection S upon probability of S. Got it? It is equation number first. Similarly, probability of A bar by S, because we have to find probability A bar by S. So what is the probability of A bar by S? In this formula we can put A is equal to A bar, so we can easily find probability A bar by S. What is probability A bar by S? Probability of A bar by S is equal to probability A bar intersection S upon probability of S. Now I have told you a formula in earlier this video. Formula is that probability of A bar intersection B is equal to probability of B minus probability of A intersection B. I have told you this formula in earlier part of this video. So I am going to use this formula in this place. If I consider S as B, so I can find this formula probability A bar intersection B. If I read S as B, so we can get probability A bar intersection B. So what is probability A bar intersection B? So probability of A bar by S is equal to, here we will use this formula. Formula is probability of B. So probability of B, what is B? Probability of B means S minus probability of A intersection B. So what is A? A means A bar minus, sorry, A means A, intersection B, B means S upon probability of S. So probability of A bar by S is equal to, we will separate denominator in each term. This gives us probability of S upon probability of S minus probability of A intersection S upon probability of S. This becomes cancelled out and gives us 1. The probability A bar upon S is equal to 1 minus, what is the value of this portion? The value of this portion is probability A by S. So this gives us probability A by S. Here is the proving of this theorem, which we have to be proved. This is the theorem number 2 for conditional probability. By this way we can prove another theorem which I am going to told you. Theorem number 3. If this theorem is very important. If capital A and capital B are two events, if capital A and capital B are two events associated to sample space S, then prove that probability of A bar by B is equal to 1 minus probability of A by B. This theorem can also be proved in same manner as theorem second. Just as theorem second. So what is theorem second? What is theorem third? A capital A and capital B are two events associated to a sample spaces. In theorem second, we have got only one event, and this theorem we have got two events. So work is same. Given us A and B. Capital A and capital B are two events associated to sample space S. Then A is subset to S and B is also subset of S. To prove that probability of A bar upon B is equal to 1 minus probability of A by B. So how can we prove this theorem? We will find first value of probability A by B, then value of probability A bar by B. So we know that probability of A by B, is equal to probability A intersection B upon probability of B. Equation number first, where probability of B is not equal to 0. This is the definition of probability A by B. So what is the definition of probability A bar by B? Same in this way, we can write probability A bar by B is equal to probability A bar intersection B upon probability of B. So I will use formula of this particular box. Formula of probability A bar intersection B is probability of B minus probability of A intersection B. I have told you in earlier portion of this video. Probability A bar by B. I will use formula probability A bar intersection B. This gives us this portion. So now it is time to separate denominator, by which we will get probability A bar by B is equal to probability of B upon probability of B minus probability of A intersection B upon probability of B. This gives us 1. So probability of A bar by B, probability of A bar by B is equal to 1 minus, and value of this portion probability A intersection B upon probability of B is probability of A by B. So this is the proof of this particular theorem. Probability of A bar by B is equal to 1 minus probability of A by B. So students, now I am going to teach you another theorem number 4, which is related to conditional probability. But for proving this theorem, you have to understand the Venn diagram of this theorem very Suppose capital A, capital B and capital C given us capital A, capital B and capital C are three events associated to the sample space S, then it is clear that because A, B and C are events and we very well know that events are the subset of sample space. It is clear that A, B and C are the subset of S, that is A is subset of S, B is subset of S, C is also subset of S. Okay, now we have to prove that probability of A union B upon C, that is, it means probability of A union B when event C is already happened. This is conditional probability of A union B when event C is happened. This is equal to probability of A by C, that means conditional probability of A when event C is already happened, plus probability of B by C, that means conditional probability of B when event C is already happened, minus probability of A intersection B by C, that means conditional probability of A intersection B when event C is already happened, and here gives us probability of C can never be equal to 0, that means probability of C is not 0. Now we have to prove this particular theorem. For this we have to find some probabilities. We have to find probability A by C, we have to find probability B by C, we have to find probability A intersection B by C, and we have to find probability A union B by C. We have to find these four probabilities, and after managing it through some lines we will find this theorem. So first thing is that we have to find value of these probabilities. It is simple, but important part is the Venn diagram of this theorem. If you understand Venn diagram properly, then you will solve this theorem easily. So pay attention in Venn diagram. So first we will find probability of A by C. We know that probability of A by C is equal to probability of A intersection C upon probability of C, where probability of C is not equal to 0. This gets us already equation number first. This is the equation number first. Now what is the probability of B by C? Probability of B by C is equal to probability of B intersection C upon probability of C. This is equation number second. Condition is probability of C is not equal to 0. Third probability is probability of A intersection B upon C is equal to, if I consider A intersection B as A, so what this probability becomes? This probability becomes probability A by C. That is probability A intersection C means A intersection B intersection C upon probability of C, where probability of C is not equal to 0. This is equation number third. And last one is probability A union B by C. So probability A union B by C is equal to probability of A union B intersection C upon probability of C by which formula? By formula of probability A by B. We will suppose A union B as A and C as B. So you will find this step where probability of C is not equal to 0. Equation number 4. Now I will solve equation number 4 and now I will solve probability A union B by C, and after solving it I will get this portion. So I will solve equation number 4. So from equation 4. Now this is part is very important which I am going to solve from equation 4. From equation 4. Probability of A union B by C is equal to probability of A union B intersection C upon probability of C. Now, Venn diagram of this situation. From Venn diagram of this situation. This part is very important. Venn diagram of this situation is very important to understand. So, what is the Venn diagram? This is the rectangle which represents sample space S, and here comes three events: capital A, capital B, and capital C. I will construct rectangle this. This is the rectangle which represents sample space, and here gives us three events: capital A, capital B, and capital C. You can see here is A intersection B. Here is A intersection B. A intersection B means common portion of A and B. B intersection C. Here is B intersection C. B intersection C means common portion of B and C. And here is A intersection C. That means common portion between A and C. So we will construct circle in this manner such that each two circles have common portion. That is, figure of A, B, and C are like this. Is like this. This particular figure. This is A, this is B, and this is C circle. Okay. So in this portion you can see what is A union B. In set you can easily understand A union B means portion of A and portion of B. This sketch gives us A union B. This sketch gives us A union B. This is the sketch of A union B. But we have to find intersection of A union B and C. We have to find intersection A union B and C. So A union B means this shaded portion, and C means this circle. So what is the common portion of shaded portion? What is the common portion between shaded portion and circle C? You have to see the common portion of A union B and C. So if you watch carefully, A intersection B is the shaded figure and C is the circle which I have drawn already. So I can easily say that this portion is the portion which is common A union B and C. This is the common portion of A union B and C. Which portion? This portion which I am underlining. This portion, and this portion. Now, if I cut this portion like this, so here is the portion. This portion is like that. If I cut this portion is the A intersection B. A union B intersection B. This portion is made by two parts, this part and this part. So I will find what is this part and what is this part. So if you watch carefully, this part is the common portion. This part is the common portion of A circle and C circle. You can see this part is the common portion of circle A and C. Common portion means intersection. So this part is the intersection of A and C, and this portion is the common portion of circle B and C. That means this portion is A intersection C, and this portion is B intersection C, and this whole portion is the combination of these portions. That is, we can write A union B intersection C by A intersection C union B intersection C by Venn diagram. So we can write A union B intersection C as A intersection C union B intersection C. Venn diagram is very crucial. You have to study Venn diagram for this problem very deeply. Then you will find the value of this easily. Probability of A union B upon C. Now, if I take A intersection C as A, if I suppose this portion as A and this portion as B, then we will find formula of probability A union B, where A is A intersection C and B is B intersection C. So what is the formula? Formula is probability of A plus probability of B. Probability of A union B by C is equal to, I will suppose A intersection C as A and B intersection C as B. So formula becomes probability of A union B. Probability of A union B is equal to probability of A, that is probability of A intersection C, plus probability of B, that is probability of B intersection C, minus probability A intersection B, that is value of A intersection C or intersection B intersection C upon probability of C. Now again we will look into Venn diagram. What is this portion? This portion is A intersection B. So in this figure, A intersection B means A intersection C means this portion. A intersection C means the common portion of A and C. So A intersection C means this particular portion is I am underlining in the Venn diagram. This portion is A intersection B. This type. This portion is A intersection C. And what is B intersection C? B intersection C means common portion of B and C. So common portion of B intersection C is this. So common portion of B and C is this particular figure, and this particular figure is attached by this figure. That is, the shape of this figure is like that. This type figure. This is A intersection C. This whole portion is A intersection C, and this whole portion is B intersection C. Now we have to find intersection of A intersection C and B intersection C. In easy language, we have to find common portion of A intersection C and B intersection C. So you can easily see that common portion of these portion is this particular figure, and this particular figure is the shaded portion by A, B and C. This particular figure is the common portion of A, B and C circles. So we can write A intersection C intersection B intersection C as A intersection B intersection C by Venn diagram. So by Venn diagram by Venn diagram. A intersection C intersection B intersection C is equal to A intersection B intersection C. Once again I will make the Venn diagram to show you properly. This is A circle, this is B circle, this is C circle, this is sample space S. This portion is the common portion of A and C. So this portion is A intersection C and this portion is the common portion of B and C. This portion is B intersection C. This portion is A intersection C and this portion is B intersection C. We have to find common portion of A intersection C and B intersection C. So common portion of both these figures. So common portion of this figure and this figure is this small region, and this small region contains the part of circle A, the part of circle B and part of circle C. This particular portion is the A intersection B intersection C. So we can write intersection of A intersection C and B intersection C is equal to A intersection B intersection C. I think you all are understanding the Venn diagram properly. If you are not understanding the Venn diagram properly, then this theorem cannot be solved. Probability of A intersection C plus probability of B intersection C, and we can write this whole part as probability of A intersection B intersection C by Venn diagram. And I am going to apply the bracket in A intersection B upon probability of C. Now it is time to separate the denominators in each term. That is, we can write this one is probability of A intersection C by probability of C plus probability of B intersection C by probability of C minus probability of A intersection B intersection C by probability of C. That is, probability of A union B by C is equal to, this portion is the probability of A by C. From equation first you can check. This is the probability of A by C. This portion is the probability of B by C. And this whole portion is the probability of A union B by C from equation 4. You can check. From equation 3. This portion is equal to probability. This portion is equal to probability of A intersection B by C. So here comes the provement of this theorem. I think you are understanding this theorem. But important thing is Venn diagram for this situation. So students, it is enough for today's class. So students, in today's class I have started a new chapter probability in which I have taught you about conditional probability, some short questions related to conditional probability and some theorems related to conditional probability. So I think you will have to learn all the important things about conditional probability, theorems related to it and formulas related to it. So students, I will continue this chapter in next video also. Thank you students.